lesson is the Gauss Seidel. The first step in solving using the Gauss Seidel is to determine if your equation is convergent. To do this, we need to satisfy a condition in which the first coefficient of the first equation must be greater than to the sum of the second coefficient and the third coefficient. For the second equation, the second coefficient must be greater than to the sum of the first coefficient and the third coefficient. For the third equation, the third coefficient must be greater than to the sum of the first and second coefficient. In this system, it is said that our system is diagonally dominant. For the second step of solving using Gauss Seidel, we need to form an equation that we will equate the first coefficient in order to find the unknowns. To do this, x1 is equal to 0.1, x2 7.85, over 3. Substituting our initial values will give you the value of 2.6166. For the x2, just equate the negative 7x2 to the other coefficient. Substituting our initial value of 0 will give us the answer of negative 2.7945. For the x sub 3, substituting again, then 71.4 minus 0.3 x1 plus 0.2 x2 over 10. Substituting the initial value of 0 will give us the answer of negative 7.1173. This equation will be used again to the second and third iteration of the Gauss Seidel method. To determine the percentage of error, our initial value, the equation for our percentage of error will be our initial value minus the values you determined before, 2.6166 times 2.66 times 100 will give us the percentage of error of 100%. Since we started from initial values of 0 from all of our coefficients, therefore our percentage of error from our first iteration is all 100%. As I've said before, that we will use the equation that I formed before. So, x1 is equal to 7.85 plus 0.1 x2 plus 0.2 x3 over 3. Then x2 is equal to 19.3 plus 0.1 x1 minus plus 0.3 x3 over 7, then x3 is equal to 71.4 minus 0.3 x1 plus 0.2 x2 over 10. So substituting our values from our first iteration will give us the value of this. For the second iteration, we'll have the value of 2.99 negative 2.4894 236.66. Note that if you find your x1, then